Hey guys, and welcome to the Voice of AI. I'm Chris, and today is our follow-on from our Introduction to AI series. Today's session is on AI-powered analytics, and together with my AI avatar team, we'll be providing you an overview of how AI is transforming data analytics. We'll start with a quick introduction to data analytics and some of the key topics that we'll be covering today. So Amy, can you please give us today's introduction? Thank you.
Sure, of course, Chris. Let's get started. Welcome to an introduction to AI-powered analytics and insights. So let's have a look into it now. If we look at AI-powered analytics, we firstly have to ask the question, what is data analytics? Well, it's extracting insights from data through statistical and machine learning models, which helps us create evidence-based decision-making. AI amplifies analytics by processing vast amounts of data, automating model building, continually optimizing, producing insights that are not possible manually. Let me give you an overview on the types of AI-powered analytics. This is the list of topics we'll cover today. Predictive analytics, which is forecasts, modeling, and recommendations. Sentiment analysis, this is understanding text data like social media. Anomaly detection is identifying outliers and risks. And optimization, which are simulations to find ideal scenarios. Finally, a brief wrap-up with Chris. Now let me pass over to David.
Thanks, Amy. Hi, I'm David. Let's take a look now at predictive analytics, which is one of the most valuable applications of AI for data analysis. Firstly, what is predictive analytics? This is the use of historical data to forecast future outcomes and behaviors. Regression and machine learning models. Techniques used in predictive analytics are the following. Regression models like linear regression to quantify correlations. Machine learning approaches like random forests and neural networks to uncover complex patterns, and reinforcement learning to optimize sequential decisions based on past results. Some use cases can be seen in the following. Demand forecasting, which is used to anticipate sales volumes and set optimal inventory levels. Customer lifetime value prediction, which identifies high-value customers for retention. Dynamic risk scoring is thus used to rapidly update credit risk models as new data emerges. And targeted marketing, which identifies which customers will respond best to offers. Let's look at a few case studies. In retail, we can forecast demand across thousands of stock-keeping units with 85% accuracy. In finance, we can detect fraudulent transactions with 95% accuracy, therefore minimizing losses. And in healthcare, we can predict the likelihood of readmission for patients to improve outcomes. And what about best practices? It's easy now to collect high-quality representative training data and to regularly retrain models on new data. We can rigorously evaluate model performance before deployment, and also monitor predictions for concept drift over time. With the right approach, predictive analytics unlocks immense value. Now over to Amelia, who will give you some input on sentiment analysis.
Thanks, David. Let's investigate sentiment analysis, which uses natural language processing, NLP, to understand subjective opinions, emotions, and attitudes in text data. The techniques that are used are often a text classification to categorize sentiment as positive, negative, or neutral. It is aspect-based to associate sentiment with specific features and often uses emotion detection to identify specific emotions like joy or anger. Sentiment analysis is very useful for customer communication with reviews and feedback, for social media posts and conversations and survey responses and product reviews. Case studies such as brand monitoring, which can easily detect PR crises and reputational threats from social media. Voice of customer, where we can identify pain points and improvement opportunities from reviews. And post-sales surveys, which can quantify customer satisfaction across support interactions. Best practices, we should develop annotated datasets covering various linguistic scenarios. Use domain-specific taxonomies tuned to vocabulary of data. Combine machine learning with rules-based approaches. For some real-world examples, let's head back to Chris.
Thank you, Amelia. Here are a few examples of how sentiment analysis is being applied. If we look at brand monitoring, companies are analyzing social media conversations to detect PR crisis and reputational threats early on. Sentiment analysis of Twitter feeds can spot customer complaints and emerging issues. Now on to the voice of customer analysis. Sentiment analysis is used on customer reviews, surveys, and feedback to identify pain points and opportunities to improve products or services. And by quantifying sentiment on key features, companies can focus on fixing what matters most. Customer service and call centers. Sentiment analysis is used on customer support calls and chat logs to evaluate satisfaction across interactions, and this provides metrics to continuously improve service quality. Another area is advertising testing. Companies are using sentiment analysis to focus on group reactions to ads and marketing content, and this provides data to refine messaging and creative for optimal response. And there's also political campaign analysis. This is where positive and negative sentiment on social media provides real-time feedback on how strategies and talking points resonate with voters during political campaigns. The applications of sentiment analysis are rapidly expanding as NLP, natural language processing models, become more sophisticated. But the key is combining AI techniques with an understanding of nuances of human language. And with the right approach, sentiment analysis unlocks invaluable insights from this unstructured text data.
Great overview, Chris. Now let's look at detecting anomalies. Anomaly detection. What are anomalies? These are rare events and statistical outliers that differ significantly from the majority. Different techniques are utilized, for instance, statistical approaches like z-scores to identify outliers. Machine learning models trained on normal behavior and time series analysis to detect deviations in trends. Some use cases involve fraud detection, identify malicious transactions and access system failure prediction, detect unusual performance to prevent outages, and medical diagnosis to detect abnormalities in imaging tests or health records. And if we look at the case studies, we can see that in cybersecurity, it is possible to detect attackers probing defenses amidst billions of data points. In manufacturing, we can identify production line failures from sensor streams, and in the Internet of Things, we can detect pipeline leaks from real-time flow sensor data. So the best practices of anomaly detection include properly sampling and labeling training data with anomalies, fine-tuning models to minimize false positives and negatives, and adapting models continuously as the concept of normal evolves. With this foundation covered, Amy will now talk through some optimization techniques.
Let's uncover optimization. This lies on finding the most efficient or lowest cost solution when given constraints. Optimization techniques used are linear and integer programming to find optimal allocations, stochastic modeling and simulations to identify best policies, and heuristics and metaheuristics to find approximate solutions quickly. Some exciting applications include supply chain optimization, where we simulate production scenarios to minimize cost. Scheduling, this is allocate resources across tasks efficiently, and networking and optimization of traffic routing on roads or websites. Case studies in manufacturing can be to optimize machine schedules to improve throughput. In transportation, to optimize delivery routes to reduce mileage, and in the energy sector, to optimize power generation and minimize grid failures. Best practices in optimization include the following: to accurately define constraints and objective functions, to continuously iterate models with new data, and to leverage human subject matter expertise to refine models. With the right approach, optimization drives major performance gains. Over to you, David.
As we've seen, AI analytics provide immense value, but ethics need to be upheld, as we have noted previously in ethics and responsible data usage. We need to always look at mitigating bias, ensuring fairness and transparency, safeguarding privacy, security, and access rights, while establishing accountability and oversight. We should be monitoring for unintended consequences and always maintaining human involvement in the decision-making process. With responsible development, we can unlock benefits while minimizing risks. Back to you, Chris.
So thanks everyone. And just to recap, AI is truly transforming analytics, allowing us to extract invaluable insights and data on an unprecedented scale. AI is transforming data analytics and business insights. Techniques like predictive modeling, sentiment analysis, anomaly detection, and optimization unlock immense value. And real-world examples show efficiencies and capabilities not possible before. But responsible development is crucial, mitigating bias, ensuring security and privacy, and maintaining human oversight is key. And with the right framework, AI analytics enables data-driven decision-making at a new scale. The future is bright for organizations leveraging these tools strategically for increased productivity, higher quality insights, and new sources of value creation. So we encourage you to continue exploring the responsible and ethical integrations of AI to enhance analytics in your organization. So good luck with that. And Amelia, can you give me 3 final takeaways for today's session? Thank you.
Sure thing, Chris. AI unlocks new levels of efficiency, accuracy, and capabilities for data analytics through techniques like predictive modeling, anomaly detection, and optimization. Real-world examples are demonstrating massive performance gains, new product insights, reduced risks, and optimized decision-making. But to realize benefits while minimizing harms, AI analytics must be developed responsibly, mitigating bias, protecting privacy, maintaining human oversight. Ethical and responsible AI development pays dividends in both positive impact and public trust. With the right framework, AI-powered analytics can drive transformative value for organizations. Thank you and see you next time.
Thank you, Amelia. Well, that's all for today. Thanks to Synthesia for providing our AI avatar team, and thanks for watching the video. And if you haven't already, please like and subscribe to our channel for more AI-related content and tips, and join me on the journey to unlock the potential of AI. And if you have any questions or feedback, please leave them in the comment section below. I'll see you next time. All the very best. I'm Chris from the Voice of AI. Cheers and bye-bye now.